Hi students, in this video we are going to discuss about the electrochemical principles that we are applying in the extraction of metals that is the metallurgy. So let us have some fundamental topic about the electrochemical principles that we are going to introduce into the extraction of metals. When you are studying in your +1, you had a chapter named redox reactions, unit number 8. At the end of the unit, you came across a Daniel cell, about the Daniel cell. What is the chapter name? Redox reactions. What are redox reactions? The reactions in which both oxidation and reduction takes place simultaneously. Those reactions were known as the redox reactions. Yes, those redox reactions we are studying in the case now how to apply in the metallurgy. Let us come to the point when we are using our remote control to control the TV. If it is not functioning, what will you check first? You will check whether the battery in the remote is working or not. If not, you will replace the battery with a new battery. And now the point is, in your day-to-day life, we are depending on these batteries. In the battery, what is present or what is it doing? It is converting the stored chemical energy into electrical energy in its functioning. Yes, in the battery, what is happening is chemical energy is converted into electrical energy. So, this branch of chemistry that is dealing with converting chemical energy into electrical energy, it is called as the electrochemistry. What is it called as the electrochemistry? Such electrochemistry we are going to link up with the metallurgy. Here I had given one definition for you. Study of production of electricity from energy released during spontaneous chemical reactions. Energy released during spontaneous chemical reactions. We are going through the same definition again. Study of production of electricity. What is getting produced here? Electricity is getting produced from energy released during spontaneous chemical reactions. We came to know when do the chemical reaction will be spontaneous according to the metallurgy conditions we followed. There are many conditions. There we had mentioned in a spontaneous reaction the Gibbs free energy must be in a negative form. How much with the Gibbs free energy? The Gibbs free energy must be in a negative form for the spontaneous chemical reactions. Yes. Now let us recall our point about the Daniel cell that we had learned in the first year. In the Daniel cell, there are two halves, two parts we can say. In one part, we have placed a beaker. In that beaker, we have taken zinc sulfate solution. That is the zinc sulfate aqueous we mentioned. Zinc sulfate solution. It is called as the electrolyte. The particles of zinc sulfate that are dissolved in the solution, what are we calling this one as? The zinc is in the form of Zn2 plus aqueous. Our metal, our consideration is with the metal. this zinc sulfate that is dissolved in water we have taken in the beaker. In that, zinc will be in the Zn2 plus aqueous form. It is called as the zinc electrolyte that is present in the solution. Sulfate is also another electrolyte. Now, in this zinc sulfate solution, we have dipped a zinc rod. What have we dipped a? Zinc rod. Zinc rod, it is the electrode that we use in this reaction. What is this? It is the electrode that we use in this reaction. Two main things you must observe. One is from the zinc sulfate, the zinc 2 plus ions that are present in this solution, they are called as the electrolyte. And the zinc rod that is dipped in it is called as the electrode. Next, we have connected that to another copper rod that is dipped in copper sulfate solution. We have connected this zinc rod with the help of the connections to the copper rod that is dipped in the copper sulfate solution. Can you identify electrodes must be dipped in the metal solutions. In the metal solutions, metal ions containing solutions. Now here, which one is the electrode, which one is the electrolyte? Copper rod is the electrode. Copper rod is the electrode, and the copper ions that are present in this solution, they are called as the copper electrolytes. They are called as the electrolytes. So electrode must be dipped in the metal ion solution. In the metal ion solution. We had learned this one under the title called Daniel cell in the redox reaction. It is a very simple explanation for Daniel cell. Here what is happening? We had observed a chemical reaction there. What did we observe? When we study the reaction here, zinc rod when dipped in zinc sulfate. Zinc rod when dipped in zinc sulfate. Both the solutions, that is zinc sulfate will be 1 molar in solution, copper sulfate also will be in 1 molar in solution. Molarity is the same. Molarity is the same. What happens here means the zinc ions from this solution, zinc ions from this solution, they will deposit on the zinc rod. They will be deposited on the zinc rod. Now, on this rod, we had already zinc. But now what was deposited? Zn2 plus was deposited. Now this electrode is becoming a positive electrode. Charge of the electrode is becoming a positive electrode because positive ions are depositing on it. At a similar time, some of the zinc atoms from the electrode will be dissolving into the solution. Some of the zinc atoms from the electrode are depositing into the zinc solution in the form of Zn2 plus. By releasing 2 electrons. See the point? Zinc from the electrode, it is entering into the solution in the form of 2 plus ion. What is happening for the zinc? Can you observe what is happening for the zinc? Zinc is losing electron. The process of losing electrons, it is called as the oxidation. What is this one called as the oxidation? These electrons that are lost by the zinc will be flown towards to the electrode of copper. Observe, they will accept those electrons. What is happening for the copper? Copper ions are accepting the electrons. Cu2 plus aqueous, they are accepting the electrons, and it is converting into metallic copper that is getting deposited on the copper electrode. That is getting deposited on the copper electrode. This part where the electrons are lost, we call it is undergoing oxidation. Then what do you call with copper? The electrons that are deposited up to here, that flown here, the copper ions are accepting them, they are deposited on the electrode. This reaction where the copper is accepting the electron, shall we call copper is undergoing reduction. Cu2 plus, they are accepting the electrons as they are undergoing reduction. So, in the case of this Daniel cell, we are observing zinc rod. The zinc part, it is undergoing oxidation, and the copper rod side, it is undergoing reduction. In this chemical reaction, the overall reaction that we have represented is zinc rod, it is losing the electrons and forming the zinc 2 plus ions. Means zinc is undergoing oxidation, copper 2 plus ions, they are accepting the electrons and they are undergoing reduction. This is the overall reaction here. What is this one? The overall reaction. But in this chemical reaction, what is happening? One side it is undergoing oxidation, another side it is undergoing reduction. It is called as the redox reaction. What is it called as the redox reaction? In this redox reaction, what is happening means flow of electrons takes place. Flow of electrons takes place. We know when the electrons are flowing from one to another place, current will flow in opposite direction. Current will flow in the opposite direction. Yes. So, during a chemical reaction, what was generated? Electricity was generated. During a chemical reaction, electricity was generated. So, this is an electrolytic cell, we can call, or galvanic cell, in which chemical energy is converted into the electrical energy. This is the basic that we have learned in the first year. Please observe, when we study the point light from the zinc sulfate solution, the zinc 2 plus aqueous electrolyte are deposited at the zinc electrode, it is becoming positive. And from the zinc rod, some ions are entering into the solution, making this one as negative. This overall movement of atoms or ions, that is creating one potential difference at the electrode. It is creating one potential difference at the electrode. That is called as the electrode potential. What is that one called as the electrode potential? Please observe the potential difference between the the electrode and the electrolyte is known as electrode potential. Electrode potential. For each electrode, there will be one electrode potential. Now we are going to study some electrode potentials of some of the electrodes. Yes, we have discussed about up to now what is called about the electrode potential. For that, we got the definition here. For a single electrode potential, we have discussed. In this Daniel cell, there are two electrodes that are between two electrolytic solutions. In that case, zinc is undergoing undergoing reduction we say. So we can say there are two half reactions that are taking place here. One is called as the oxidation half cell, where zinc is undergoing, and another one is the reduction half cell where copper is undergoing. So at these two electrodes, now we are comparing the potential that is developed between the two electrodes. It is called as the cell potential. The potential difference that is developed at the two electrodes in the Daniell cell, we are calling as the overall cell potential. It is measured in volts. Let us see the definition here. The potential difference between the two electrodes of galvanic cell. Between the two electrodes of the galvanic cell. What are the two electrodes? Zinc electrode and the copper electrode of the galvanic cell is called as the cell potential. This overall cell potential we can say it is generally represented with the symbol E0. How is it represented with the symbol E0? It is also given in this equation. E0 of the cell means the potential difference of the two electrodes. The differences, they are mentioned as electrode potential of right hand side minus electrode potential of left hand side. This right hand side, we observed copper rod is present on the right side. On the left side, which rod is present? Zinc rod is present. These are also given as electrode potential of reduction half cell minus electrode potential of oxidation half cell. Each electrode will have one potential. That is called as the electrode potential we mentioned. Now, when we have the difference between the reduction half cell potential and the oxidation half cell, we will get the cell potential, total cell potential. How is it measured? We mentioned it is measured in volts. Here, when we don't take out any current from the so-called Daniell cell or this galvanic cell, it is called as the electromotive force of that cell. What is called as the electromotive force of the cell? In short, it is also called as the EMF. EMF. See, it is called the cell potential. It is called electromotive force. EMF. When no current is drawn through the cell. When no current is drawn throughout the cell, it is called as the EMF of the cell. So, these 2 points are needed for the basic fundamental. See here, we already mentioned when the zinc rod is immersed in the zinc sulfate solution of one molarity, means they are in a standard form. And the so-called electrode potential, we call it as a standard electrode potential. I am repeating once again. When the concentration of the ions or the species, when they are unity, that is 1, we call the potential of that electrode as a standard electrode potential. See the definition here. When the concentration of all the species, that is ions, involved in the half cell, in a particular half cell, is unity, that is 1. The electrode potential is known as the standard electrode potential. They had observed for each and every electrode, there was some standard electrode potential at 298 Kelvin. At 298 Kelvin. And sometimes we may get a doubt. Why only zinc will lose the electrons, whereas copper will gain the electrons? Why not it will undergo reverse? For the highly reactive metals, their electrode potential will be in a more negative form than the less reactive metals. Now we can say the less reactive metals will have less negative or positive electrode potentials So by seeing these electrode potential values, we can say which is a highly reactive metal and which is a least reactive metal. We have brought a small concept regarding standard electrode potentials at 298 Kelvin. See, in a reaction, there is oxidation form is converting into reduced form. The electrode potential, how is the electrode potential measured? The cell potential or the electrode potential will be measured in the form of volts. Cu2 plus, when it is converting into Cu, its electrode potential is 0.34. How much is electrode potential? 0.34. Whereas zinc electrode potential is minus 0.76. Minus 0.76. What did we mention, children? The highly reactive metals, they will have a negative electrode potential. So which is highly reactive metal here? Zinc is highly reactive metal as it got a negative electrode potential. And copper, which got a positive electrode potential, it is the least reactive metal. It is nothing but a kind of displacement reaction in which highly reactive metal displaces the least reactive metal from its salt solution. That is the fundamental we had learned. But our fundamental we are giving up that we are getting how to calculate the electrode potential of this cell. So reduction half cell minus oxidation half cell electrode potential differences we need to make. Which one is undergoing reduction? The reduction half cell will be the one which has the positive electrode potential. And every time the oxidation half cells will have a negative electrode potentials. By this we can solve any of the bits whenever the clue is given there. Shall we apply the formula here? In order to calculate electrode potential of the cell, reduction half cell, which is undergoing reduction here? Copper is undergoing reduction. What is the electrode potential of the copper? 0.34 volts minus. Which one is undergoing oxidation? Zinc is undergoing oxidation into Zn2 plus ions. What is electrode potential? Minus 0.76. So minus 0.76 volts. So minus into minus. So we can add this one as to give 1.10 volts. So the overall electrode potential, that is the cell potential, in this case, how much we got? 1.10 volts. This is the fundamental that we will learn in the electrochemistry. Now we are going to apply this into our metallurgy. Remember the key points, children? What is meant by cell potential? It is the difference between the potential differences of the electrode potentials. The oxidation half cell will have a negative electrode potential, whereas the reduction cell will have a positive electrode potential. So when these negative and positive we have a difference, we get a positive, that is more electrode potential. If this electrode potential is getting more, if the electrode potential is getting more positive, if the electrode potential is getting more positive, then we need to study that a new reaction here. We are having a new reaction for our metallurgy. When the cell potential is getting more positive, the Gibbs free energy becomes more negative. When it is getting more negative, we can say it is a more spontaneous reaction. For this, we are applying this formula into our metallurgy. Delta G naught equal to minus NFE E naught. Here delta G naught represents the Gibbs free energy. N represents the number of electrons that are flowing from the oxidation half cell to reduction half cell. Faraday. 1 Faraday. It is 96,500 coulombs in the unit measure. E naught is the electrode potential. So let us apply this into our metallurgy. So we have discussed now that if the differences of two electrode potential values corresponds to a positive electrode potential, we have discussed about the Daniel cell, the E naught of reduction half cell minus E naught of oxidation half cell. We got a positive value. It consequently makes the delta G negative more negative. When the delta G is getting more negative, what will happen? When the delta G becomes more negative, then this is an spontaneous reaction. Further, we are given the difference. Delta G is called Gibbs free energy, and is the number of electrons. F is the Faraday. E is the electrode potential of the redox cup, reduction half cell and oxidation half cell. So in this electrochemical principles, 2 points we need to study in detail again. If you are using an solution, that is electrolyte is dissolved in water, it is called as the electrolytic solution. Electrolyte is dissolved in the water is called as the electrolytic solution. There, that electrolytic solution, it need to undergo electrolysis to get our metal. It need to undergo electrolysis to get our metal. But if our metal is in the liquid state, that is called as the molten state, then we need to use some reducing agent. The metal is in the molten state, then we need to use some reducing agent. See the points. Reduction of metal ions in the solutions. Reduction of metal ions in the solutions are done by electrolysis, whereas reduction of molten state metals are done by using reducing element. Based on these two main concepts, we will apply these electrochemical principles into the metallurgy, and in the next video we will see how to get the aluminium from the bauxite ore by hot Herod process.